Hi, this is Andrei. We continue the series of our tutorials for Luma-mu, and in the previous video I explained the usage of these in a waveform oscillator mode, where you put the actual waveforms on this and set it to the loop position by removing the jumper. So in this video we continue talking about this by looking at the software that's designed to create these waveforms. And this software is outside of Luma-Tools, but Luma-Tools are used to import the waveform data that was generated by this software. And I'm not calling the name of this software because there are multiple of the applications over the time. There is nothing new in the wavetable synthesis. Overall, it exists for years, for decades in software and the hardware. And so there are tools created over decades, again, that designed for that. In this video, I'm not interested to give you a review of each tool, but my goal is to explain how you can take the data out of the particular sets of the tools and export that in a way that Luma-Tools can understand this. And we will be focusing on this. I prepared the several, actually I prepared the list of the tools that we will be using, and created a small setup that can help us understanding this. So we will be using the same small skiff that I have here with 3 Luma-mu. We will be using only the rightmost with the reach around extender. On this reach around I have Pico-ROM EEPROM emulator installed. We don't have any CV inputs connected. We don't need it. We have the output connected, and we have that gate module that I found handy just to interrupt the, to stop oscillator running when I need some silence. Okay, so that's what we will be using. On the laptop side, let's switch over to these. Of course, our primary tools are Luma-Tools, so you go to this https / Luma.Tools and you get there. You have to run it in a Chrome browser. I keep repeating this. I think it's important to keep reminding you about this. So I prepared several tools, and we will start with the only tool in this list, which is a commercial tool. The name of that tool is Wavetable Creator by OceanWave. And well, the reason I brought it first, well, first of all, you say it's a 40 euros. It's on sale. I mean, it's been on sale a week ago, and I'm sure you can buy it at a lower price than 40. But it's a good visual tool. We will be using as a basic reference. To be specific what we are trying to achieve, this tool not necessarily fits all the needs that, well, we have, or I personally have, and let me show you this. So the way it works, you have 2 waveforms that can be also, well, processed heavily and shaped with external shapers and can interact to each other, so you can create really well, interesting sounds. But also, when you set up each waveform, you set up through the 5 independent waveforms that start early, middle, late, end. So that is basically over the time that you create. I will show you how you select what time you generated. You transition through these 5 waveforms. They don't need to be well, different. They can be the same, like in this screenshot, and so this tool is really designed for the wavetable synthesis that is not limited in the memory capacity. With Luma-mu, we have 8 sound slots, as you know, and each slot is about 1.5 seconds. So when you think about this, if you put some evolving waveform like what the OceanWave tool can design, it's a pretty short loop, so it gets annoying quite quickly. Instead, what I really enjoy, I like putting the static waveforms into these 8 slots and switch these slots by applying the CV voltage and applying some, well, external control like we saw in another video. And by doing that, switching waveforms and creating some character of a sound, which is, well, let's call it sort of a PPG, type of things to do, and this is what I'm trying to really replicate in this regard. But for 1.5 seconds, using the tool that creates that long sweeping and or morphing well, tones and wavetables, just something that's not appropriate. Anyway, we can use it. The disadvantage of, well, that's how they specialize it, but the disadvantage is that you cannot select the waveform yourself. So you have to take it from the pre-selected list, but you cannot design it yourself. So, but really, I'm going to show you how to use it. So we start with just a static waveform. We take all the signs. We have to have our file output at 48 kilohertz. This is important for Luma-mu. I'm sorry, well, that's important for Luma-Tools in the first place, because when you generate it in that way, then the Chrome imports the wave file. It sets you to a precise offset. So if your wavetable is sample accurate and loop accurate, in this case, at the 48 kilohertz, that's also imported accurately. If it sets to any other type of like a sample rate frequency like 44.1, it won't be accurate, so you'll hear the pop sound and it will be looping. That's just to keep in mind. So that's what we set to 4800 frame size. What is a frame size? So think about that. We have to draw our waveform within the number of frames. These frames are power of 2, so it's like 256, like in that case, 512, 1024, and so on. And this frame size is basically defines how we draw this waveform. And that also, well, that on the other end, so you have, that defines a single cycle, and then you can multiply this cycle. So in this case, cycles 512, it means that we take this frame size of 256 and then multiply it to 512. So we get not a single cycle wave output at the end, we get it multiplied by 512, and that's actually what we need, because at the end of the day, we will import that to the Luma-Tools, and Luma-Tools will trim it to the size of this waveform, EEPROM. And so then everything will be accurate, because everything is in power of 2 relations. Anyway, let's take a look on this. I will click File, and it creates the file of these given parameters. And again, I'm using just a sign for ease of use, because we need to start with something, and we will be creating our own EEPROM. So I go to Luma-Tools. So I select Luma-mu by default here, and now I drop the wave file that is here. And I drop it to the main window, and from main window I drop it to a slot. So that's a slot 1 represents, it's actually slot 0 on the digit, because it starts with 0, and here it starts with 1. We will update it later. So then I click Program to Pico. My Pico is connected, Pico-ROM connected, and so now I can program it. I can move here, put it to the 0 position, and listen it. Wonderful. So no pops, no clicks, everything is great, and so everything is precise and accurate. Again, I started with a commercial tool. You can get a lot from this, honestly. So it's worth paying this amount, because there are lots of waveforms, and you might be also like really enjoying in doing some experiments in the transitional or morphing waveforms. And it might sound all right, depends on what we are trying to do and achieve. So enough with this, we will move to the next tool. And the next tool is by Paul Schreiber, who unfortunately passed away recently. And the name of that tool is WaveEdit. He designed it, and he designed it with some developer, as I remember, to support one of his digital oscillators. And they're very capable. I believe they first were designed for modern format and then moved to the era rack. I might be wrong, but the tool is cross-platform. It's available for for Windows, Mac, and Linux, and in the source code you can compile it for something else. So my point is that it's a standalone tool, and I have it downloaded here, so I can run it. We call it WaveEdit, and it's here. So what WaveEdit does? First of all, it's really nicely looking and very good layout, very good thought in this just overall, because you think, well, with all of these complexity, there is a very simple visual form to show that what you can do with this. So first, here on the left side, you have a single cycle waveform slots, and total you have 64. And you point which slot you want to listen, but you can also point in the middle, and that would be a morph in between these two, and that's what oscillator is doing. So in our case, we just draw this waveform. Let's put something like this. We can draw it, we can create these with harmonics. We can apply different modifications to this as well. We can add different shapes with the shaping tools. I mean, everything is awesome. And plus, you also have a set of presets that you can start doing something with them. Anyway, so let's preview this. So this is how the single cycle sounds of this waveform. Now the thing is that if I leave it as this, well, you will see that the export wouldn't be what I would need for Luma.Tools, because I don't want to use the single cycle waveforms. I need really to have my 1.5 seconds. And surprisingly, that 64 slots is exactly what I need to get to this capacity. So what I can do now, I can say duplicate to all, and in that case, all this first waveform that I designed here duplicated for all other slots. And if I select the file save bank and save it to downloads and give it a name, let's say WaveEdit. So it saves actually when you look on your file, it's actually saving the WAV file. And WAV file is just concatenated all of these 64 waveforms. That's exactly what we need. However, here is a problem. This WAV file is 44.1 kilohertz, and we need exactly the same amount of data in 48 kilohertz. And we don't need to resample this data, so just stay with me. We can lose the pitch and frequency by moving to the 48 kilohertz. Basically, all we need to do is to change the attribute of that sampler rate in order to import that to the Luma-mu tools. So the way you can do that, again, to my biggest surprise, you can do that with the free tools, and in that case, we will be using Audacity. Who could think that Audacity can do that? But I just figured that out, and looking for how you can do it in commercial tools, I realized that this tool can do it for you, and it's free. So I just loaded it here, and you see I go to the rate, and it says 44.1. If I switch to 48 kilohertz, unlike asking you, would you do the sampler rate, resampling, it just changes the sampler rate, so you see that it's shorted in the time, and that's exactly what I need. So now, once I did that, I go to the export audio, I select export to the computer, it will go to the downloads folder. I will give it a different name, 48K, so it goes to a mono, 48K, 16-bit, export. And now, of course, I can close it, and now I go back to my Luma.Tools, drop it here, and drop it to the slot. In that case, it would be slot 2, so that is would be digit 1 on the Luma-mu, and let's hear it. Programming, done, change to 1, and listen for it. Perfect. It's sample accurate, it's loop accurate, and we just learned another tool. Well, really, WaveEdit is a great tool. You will find so many things that it can do. I scratched the surface. I only showed you the basics, but this is what you need to learn in order to import that data into Luma.Tools. So we are moving to the next tool. And next tool is free again. But unlike WaveEdit, this tool is based in the browser, and we will be using, I'm using that in Chrome, as you see. And we will be creating a waveform using this tool. So the way it works, again, there are some tricks that you have to remember about this, because every tool does it slightly different, and so you have to learn and memorize these tricks. So this can do a lot of great stuff, and again, let's play it. I currently have a sample duration 512. I can move to the 256, so it goes to the higher pitch, obviously. This one, multiple waveforms, defines how many times I'm going to repeat it, right? So like in the OceanWave tool, that was a cycles. Here it's called number of waveform, basically how many times I'm going to make it. So I say 256, or even better, I say 512. Okay, great. It generated that. And in order for the tool, so we can play it way longer. Okay, great. And now in order to export the loop accurate data, we need to set two positions here. First one called loop point, it has to be on. And the other option, which is enabled by default, called reduce glitch, we have to disable. I don't know why it is. It has nothing to Luma. It's just this, I don't know, tricks of this tool to use. So you reduce the glitch, you set this to on, and then you click save, and it downloads a WAV file. And so this WAV file is here. But this is not it. This WAV file is actually 48 kilohertz. So you might say, great, I'm going to import that to Luma-mu directly. In fact, you cannot. And in fact, this is again not related to Luma-mu, it's related to some other data or metadata that's inside this file that we need to clean. So if I just drop it here, you see it complains about some data unexpected. So what I'm going to do, I'm open this WAV file again in Audacity. It's just really eyes-opening to me today. And in Audacity, it's already opened in the right way, so it's a 48 kilohertz sample rate. And all I need to do is just export audio again. I don't know what Audacity stripes out of this data, but if I look at the resulted file, you'll see that it's a half of the capacity of my original file. So something that web-based tool is doing that it shouldn't be doing. Anyway, now with this waveform, I can drop it here, and I can drop it here. And did I really create another sine wave? I did. Okay. So we can load it to Picarom. And let's listen it. It's in the slot 2. Sample accurate. Outstanding. So, and loop accurate. Outstanding. So now let's move to the next tool. So we looked already at 3. So we first looked at the OceanWave wave creator, now synthesis technology, WaveEdit, and now this one-cycle waveform generator. Now we're moving to another browser-based tool. It's called waveform generation. By the way, I'll put all the links down below in the description, so you don't need to search for this. And let's take a look on these capabilities. So this tool by design only generates a single cycle waveforms, which is not exactly what we want, but there is a way around. And this waveform generation, it offers several, well, let's call it, well, very simple to use, tools to generate different types of waveforms. So for instance, I went to the harmonic generator, and this is basically where you can apply some harmonic algorithms. And depends on where you go, you have different options, but most of them look like this. They're very easy to again to navigate, because there's not much you can change, but there are different algorithms that you can pick from. Anyway, so this is, well, let's say this is my waveform. I can adjust how many harmonics I want to see in it. So that's our preview. We set it to, again, to 256 sample size for waveform. We click save. And if you look here, so it's saved, and certainly, yes, it's a single cycle waveform. So what can help us to multiply this waveform? You guessed it, it's Audacity. So we go, ooh, unbelievable, it failed, but let's do it again. I want to make you. All right, so somehow it recovered one file. That's okay. I can tell you that did not happen to me before. I don't know, is it related that I'm also doing a screen capture and a camera capture from the same laptop, and I don't know, and also have Luma-Tools running. Let's assume we haven't seen this. So we go here, this is our waveform, so we can play it. It should be accurate, I think. It should be just a glitch of the a playback. And now I found in the tools of the Audacity a way to multiply. And now I need to find where was it. A way to multiply. Oh, that's here. So I have to select the waveform, and then I have to special tools. That's here. No, special. Way to repeat this. We first need to select it. Go here, effects, special, repeat, and we put how many times? And let's put 256. Oh, let's put 256 should be enough. If it's 256 sample window, we do 256 times. And now let's save it, export. Oh wait, let's double check. What is a sample rate? We have to switch sample rate as well. So now we change the sample rate, we multiplied it, we do export audio, we do export to the computer, and well, let's have some name like this. Great. I don't know why it failed, but I hope it won't happen to you. So now we go to Luma-Tools, we use another slot, let's drop it here, and let's drop it here, and now let's upload it. And here in the window it shows slot 4. In fact, we have to go to the slot 3 here, and let's listen to this. Outstanding. So what it means, basically, you can take the single cycle waveforms, you can multiply them, and so you can still use it with Luma-Tools. We need to think how we could make it simpler. Maybe within the Luma-Tools we can add some capabilities for doing some of these operations, but well, really, I think at the end of the day you'll pick one tool that you like the most, and you just remember your path and you never go to other tools again. All right, so we are almost at the finish line, and for the finish line I prepared to talk about the tool that is really very known and quite an old, and was designed over 15 years ago, and last time was updated like 10 years ago. It's called Audio Term, and it sort of reminds the Fairlight window, and you probably know that I'm restoring a lot of fairlights here, so it's close to my heart. But it's very, very unintuitive to operate with this, and there is some learning curve as well. Anyway, so another problem of this tool, that because it's quite old, it has never been compiled for the anything but Windows, and we have to run it on a Mac, and I'm on M3, so we have to deal with something. And the easiest way to deal with this is basically run it in the emulator, and for this reason I'm using Wine, which is very, very known and and old as well, but still supported x86 emulator, and of course it can run on ARM. And on top of Wine, I'm using a package called Whiskey. So Whiskey is basically the it's a user-friendly, Wine is not user-friendly. It's a user-friendly way to just run the Windows applications with a single click without any needs for any type of virtualization or emulation. It just creates you that emulation layer that you need to run this, and that's it. So it was very simple to do, and you just drop the program that you want to run into it, and it does for you. So now I'm going to start audio term, and keep in mind, behind the scene it will run inside the Wine. So well, think about that as a Windows application, but with such a special tricks. Okay, so to run this, you just double click on this, and this is how it looks, audio term. What we also need to have access to is its application folder. So we have to go here, and this is the data folder that we will be using later. So it started, and we need to select a different different sound output if we want to hear a sound first. I think we want to hear some sound, and it currently goes to my you see, to my speakers, and I just need to change it. Oh wait, I changed the wrong thing. So we go here with out device, and we will be using my Thunderbolt interface. Great. Now go back to menu, and there are several synthesis options. We will start with, again, with a basic called K-term. We will design and slice these. So basically, let's do slice first. That's a harmonic view. That's not the envelope view, and we can preview this. We can well, listen to this slice. Yeah, sure, lots of harmonics. Let's close this. Great, and that would be what we need. So now we have an option. We can technically export this as a single cycle waveform, and do the same trick as I did with the previous tool, web-based tool, or we can populate all the slots here. So that's what you see here. These are slots similar how the WaveEdit is doing. And to do that, if I'm not mistaken, let me look at that. We have to yeah, that's what I did. We just have to copy all the data that exists in this slot. So now if I play it, it won't be changing, right? So it's the same waveform that I generated. And we go back to the disk. We select the file type. Yeah, you see, there's no documentation for this. You have to learn this. And we have to select the tree that is a K-term wavetables. We go here, we selected this, and only now you can see the save button. So we have to press save, and now we need to give it a name. So let's give it a name. I don't know, test would be our name. Done. So now this wave file should appear. Oh wait, I didn't call store. No store. Great. Now this wave file appears here. We can preview it again. Perfect. We can load it into the Audacity. Check the well, sample rate 48K. Switch to this. Now we can do export audio like we did before. We will give it a name, and so we go back and drop this into Luma.Tools. So give me a sec, and that would be it in a wave folder, in the downloads folder. This waveform, we can load it here to the slot 5. Now I'll program it to the picker ROM, and we can listen to this in the slot 4, obviously. Perfect. So we used all the tools, and with every of these software tools that I demonstrated, we got success. I really hope that you will take that more as an instruction, and you will develop your own path, how you create a wavetable, well, waveforms for this type of a wavetable synthesis. And at the end of the day, well, have fun with Luma, and we created a multiple waveforms. In my original thinking, we should be creating the all the 5 different waveforms, but it was really not about waveforms, it was about the process. But I wanted to show that you can change these waveforms while playing. And it remains to be sample position accurate. So that's the trick of running everything in the hardware. No jitter, no delays, no glitches. Well, or there are glitches if you want them. All right, well, thank you. See you next time. Goodbye.